So when I ask my students about Newton's third law, if they have studied, most of the time what they will say is this first line here: for every action there's an equal and opposite reaction. Now this is an okay way of describing Newton's third law, but not very good for answering questions where you have to find which of the following is a action-reaction pair. I prefer the second way of describing Newton's third law, which is stated here. If body A exerts a force on body B, then body B also exerts an equal and opposite force on body A. So if you think about that second way of describing Newton's third law that I showed you earlier on, then you have to answer the question, for each of the forces that's acting, right? Which is your body A that's exerting the force, and which is the body B that is experiencing the force being exerted on it. Okay, so we can look at this example here of a cute dog on a bench. Okay, so let's say I just use this square to represent the dog, and it's on the bench here, right? From this diagram, right, actually there are two separate bodies here already. So in order to not confuse ourselves further, we should actually draw separate free body diagrams for each of these bodies. So one for the dog and one for the bench. Okay, so let's look at the dog first. What are the forces acting on the dog? Most of you will be able to tell that, okay, there's one weight and there's also a normal contact force N. Now, most of the time when you draw free body diagrams, it kind of stops here. And what I recommend, right, is you need to go a little bit further than this. So for force N here, normal contact force, you have to ask yourself, it's a force, normal contact force exerted by which body? And it is exerted on which body? Okay? And similarly, for the weight, you also have to specify, or at least be aware of, weight exerted by who? Okay, and then it's exerted on who, right? So hopefully you are able to tell that the normal contact force is an upwards pushing force exerted by the bench on our doggo over here, right? And similarly, for the weight, I hope you are able to tell that weight is just a word used to describe the gravitational force exerted by the earth on the dog. Okay, so this is a very important exercise to go through, because from here you can identify who is the body A, who is the body B, and in this case maybe there's even a body C involved. Right? Now, a very common mistake that is made is because this normal contact force and this weight happen to be equal in magnitude and also happen to be opposite in direction, then students think that this is a action-reaction pair. This is not correct, okay? Because if we look at it carefully, let's say our dog, let's call our dog body A, right? And the bench body B, then you can see here that the earth, right, is a third body, right, among these things. We have to call it a body C, right? So here you have one force that is exerted by body B on body A, and then here another force is exerted by a different body C, also exerted on body A. So they don't fit into the A exert on B, B exert back on A kind of pattern. Let's look at the bench now for an example. So the bench, right, is experiencing a downwards pushing force due to the dog resting on top of the bench. So this dog is going to push down on the bench, and the bench is going to experience this downwards force N, right? And this is the normal contact force exerted by the dog on the bench. Okay. Similarly, the bench is also affected by gravity, so the bench also has its weight, which is exerted by the earth on the bench. Okay, and then the bench is resting on the floor, so the floor is supporting the bench, pushing it up, right? So you have another normal contact force by the floor on the bench. Okay, so if you look at this original ABBA thing, you will, I hope, be able to see that this normal contact force exerted by the dog on the bench is the action-reaction pair to the normal contact force exerted by the bench on the dog. Okay, so they actually appear on different free body diagrams. Okay, so in summary, we are always going to look for this pattern. Some kind of force by body A on body B. Okay, and then the corresponding action-reaction pair force will be by body B back on body A. It's like you change the A and B position in the sentence like that. Okay, so let's try to put this into practice in a couple of examples. Alright, so here we have a typical question. Diagram shows a person using a rope to pull the block on a rough surface to the right. The block moves at constant speed. Which pair of forces is a pair of action and reaction forces? So you see, when you have a question like this, all you have to do is, for each of the force mentioned, you just need to identify your body A and body B, or maybe even body C. So frictional force acting on the block by the ground. So on the block by the ground, so this is acting on the block by the ground, and the pulling force on the block. So this is also on the block. Pulling force by who? Who is pulling the force? Which object is pulling the box? This is actually by the string. Okay, so this one is a different object, object C. So A, B, A, C. No good. So A, wrong answer. Okay, then we look at option B, the pulling force on the block. This one, you see, they didn't really specify. This is the pulling force on the block. Then you have to fill in the blank yourself by the string, or they call it a rope here. So by the rope, right? And the tension force experienced by the rope. So the rope is experiencing a force, and this is because the rope is being stretched by the box. Okay, so B looks very promising, right? Because this is A, B, and B, A. Okay, A exert on B, B exert on A. So let's keep B, and just for the sake of checking, let's have a look at C and D as well. So the weight of the block, this one you have to know that it's gravitational force. It's by the earth on the block. Okay, so let's call this A, B. And the normal reaction force acting on the block by the ground. So this is also by the earth on the block. So this one, right, it's A exert on B and another force that A exerts on B. Both is from A exert on B. It's not A exert on B, B exert on A. Okay, so C is out. And then finally, the last one, frictional force acting on the person. So frictional force acting on the person, this is by the ground. The ground is exerting a frictional force on the person. And then the frictional force acting on the block by the ground. So this next one is by the ground on the block. So you can see here the pattern is by the ground, A exert on the person, B, and then this one is by the ground, exert on the block, which is a third object, C. So this is A exert on B, A exert on C. So D is also out. So the correct answer in this question is answer B. Okay, one final example. So here we have a figure showing a man pushing a 30 kg cupboard with wheels mounted at its base. And then we are supposed to draw two forces. One represent the force that the man is using to push the cupboard, and another to represent the frictional force on the floor. So the man is pushing the cupboard like that, right? So this is force 1. And then another force representing the friction on the floor acting against the wheels of the cupboard. Oops, that's... Okay, so the wheels will experience a frictional force like this. Okay? So state and explain if these two forces are an action-reaction pair. So let's look at what each of these forces represents. This force F is by the man on the cupboard, right? The friction is by the ground on the cupboard, right? So man exert on cupboard. So this A exert on B. This one is a third object, C, exert on B. Okay? So from here you can see it doesn't fit into the body A exert on body B exert a force back on body A scenario. So these two forces are not an action-reaction pair. Okay? Even though they are opposite and maybe also same magnitude. So remember, every time you look at a force, always remember to try to identify who is exerting this force and who is experiencing this force. Label those bodies, body A, body B, maybe even body C or body D. Then from there, then you can more easily find your action and reaction pairs. So I hope you found that helpful, and thank you for watching up to this point, and see you in the next video.